So we're going to be using the SAT practice test online digitally, so that way it makes it a little bit easier for you. But and the most important thing is I did have a chance to send along this form here, the entire practice problems of all 189 problems, right, for you. So that way you guys can use it. And as we're going through and writing it down, so you have inside of your email, you should have a full PDF document that you're welcome to print and use as we're going through these problems. So that way you know where to find it. Okay. So let's start to move into everything. So first, what we're going to begin covering are the ratio and proportion concepts that are found on the SAT. So here we have a collection of problems that have been collected right from the SAT Blue Book, and to help really make it easier or more efficient, we're going to purposely do a bunch of these problems together rather than hopping test to test to test, right? So that way you guys have it there for you. All right. So here, the first type of problem that we have is stating in a random sample of 200 cars of a particular model, three have a manufacturing defect at this rate. The moment that they say rate, you should be registering that this is some sort of rate and proportion problem. It says how many of 10,000 cars of the same model will have a manufacturing defect. Well, what you want to do is you want to notice the units, right? Because this doesn't have to be cars. It could be any sort of ratio and proportion problem. And you want to notice the units. It says in a random sample of 200 cars of a particular model, three have a defect. So out of 200 cars, there will be three of which with defects. So these are going to go together, right? These essentially kind of equal each other in terms of that rate. Per 200 cars, you have three defects, or three defects per 200 cars. So either way, they can be over each other. It doesn't make any bit of difference. Now, I want to set a proportion, and a proportion, by the way, is simply equal rates. Okay, so a proportion is when I have this equal sign here, and I'm having two separate rates. And odds are I need to figure out one of the missing pieces, right? I need to figure out what one of the missing kind of units. And it says at this rate, how many of the 10,000 cars? So notice I'm going to put 10,000 cars on the top here. Now, to be fair, this question is not incredibly difficult, right? This is a section 3, but being able to break down the problem is essentially the same for any type of ratio and proportion problem. That's why I'm starting fairly simplistic, and then the problems will get a little bit more complicated. Now, it says of the same model will have a manufacturing defect. So this is like X defects. So I want to know how many defects I will have per 10,000 cars if my rate, right, is 200 cars per three defects, because it says at this rate, at this same rate. Now, in order to solve this, what I want to do is I want to cross multiply. And remember, I'm in the non-calc section. Well, you may not be aware of this, but for this type of problem, I am in this instance. So I'm going to show you kind of different tips and tricks as you're solving this mathematically. So here I'm going to have 200 cars and then times X defects. Okay. And then this is going to be over let's see here, and I'm doing my X defects. And then this would be over my three defects, but I'm not going to do that. I'm just going to do equals, and then I'm going to do my three defects, okay, like this. And then times 10,000 cars like this. Okay. And what I want to do here is I want to get X defects by itself. So I would divide both sides by 200 cars. I was going to do it in a faster step, but I didn't know if you guys would be comfortable with that. So here we are, right? So now we have 200 cars divided by 200 cars. Over here, I have to also divide by 200 cars. Because I'm doing this, notice what happens here. My cars and my cars unit will cancel, and then I'm going to be stuck in defects, which means now what I want to do is simplify this. So this becomes 30,000, right, cars, or 30,000 defects over my 200. And now I just want to divide like this. So this becomes 300 divided by 2, right, as I simplify, and 300 divided by 2 is 150. And my units should be in defects, which they are, and therefore A is going to be my answer, right? So fairly simplistic of how to break this down. Notice we are in the non-calculator section, so you definitely want to be able to do, right, 30,000 divided by 200 in order to simplify this to make it easier for you. Setting this up, though, I would say is kind of the core idea of why I started with this problem, okay? So moving into additional ratio and proportion problems, let's do this one. Now, this one is a little bit different because, it says the peregrine falcon can reach speeds up to 200 miles per hour. The moment you see the word per, you were immediately thinking of a rate of some capacity, and it says while diving to catch prey, making the fastest animal on the planet while on dive. What is the peregrine falcon's maximum speed while diving to catch prey in feet per second? Round your answer to the nearest whole number. If you see this, and here's a huge master tip, if you see this, where you will have some sort of parenthesis, and they are giving you, like, they're giving you a unit, right? And they're, or units, right? And they're giving it to you in parentheses, you will need to do a unit conversion, okay? 9 out of 10 times, you need to be aware that you're going to do some sort of unit conversion. This technically would be probably more related to a unit conversion problem, but unit conversion problem are related to rates because this is going to be in a fraction. Okay, so let me know if you guys have questions along the way, right? Feel free to drop the what you need inside of the chat just to make sure that you have everything you need. But this is saying in feet per second. Also notice this, if it says round your answer to the nearest whole number, if you see this, okay, if it says round your answer to the nearest whole number, what this is signifying is that you should expect a decimal. And if you're expecting some sort of decimal, you need to just be aware. Now, because of the question, this is question 37, this is in a calculator section, okay? So you can use your calculator, but it's just ways to think about the problem and kind of ways to associate of what to expect. First thing is, if you're given these types of parentheses here, and it says, 1 mile equals 5,280 feet, always expect some sort of unit conversion. Second thing is, if they say something like round your answer to the nearest whole number, I should expect some sort of decimal. All right, great, cool. So that's the way that you want to interpret the problem, and that's the way that it's going to make the most sense to you. Now let's break down, what do we do? Well, here it says 200 miles per hour, right? That's your speed. So if I start with 200 miles like this, okay, per 1 hour, now I want to convert this to, let's see here, feet per second. Okay, so I'm trying to go miles per hour to, let's say, feet per second. Okay, and as I'm going to end up doing my miles per hour to feet per second, I have to remember that my miles are units of length, so these will be converting, and then my hour and my seconds are going to be units of time. I will tell you that the SAT will expect you to know time. The SAT is going to expect you to know, let's say, 60 minutes equals 1 hour, and they're going to expect you to know that 60 seconds equals 1 minute. That is the only conversion unit of, well, to be fair, let's one more. 12 feet, or sorry, 12 inches is going to equal 1 foot. Okay. So the only other one that they will expect you to know is 12 inches is going to equal 1 foot. So these are the three that they will take for granted that you know, and you know well. Okay. All right. So now we have miles per hour, and I want to convert this to feet per second. So I'm simply, now here's the master trick of how you do any sort of unit conversion problem, is I want to cancel my top unit in order to get it to a new desired unit. My desired unit of length in this case is going to be feet. Okay, this is in miles. So I need to go from miles here to feet up top. Well, my unit conversion is this: 1 mile equals 5,280 feet. If this was reverse, if this was like 200 feet, then I would put feet down here at the bottom and the miles on the top. And that depends on the way that I'm going to be multiplying it. Because look, if I do miles times 1 over miles, then these cancel, okay? Also, a quick consideration is that the number, or what we refer to as the coefficient, that's out in front of the unit is the number here that they're providing, right? That's what the conversion is. So here I have 200 times 5,280 feet, now over hours. So now I have feet over hours in terms of my answer. I'm not done yet though, because I want to go feet per second. So if I were to erase this just to make a little bit more room, then I'm going to now multiply, and my hours are going to go on the top right? And I want to go to seconds. Well, I'll do a somewhat long way, right? I'm going to do 60 minutes first, like this. And then I will do my minutes on the top, like this, right? And then I will do 60 seconds, right? So 1 minute equals 60 seconds, 1 hour equals 60 minutes. These cancel, and I keep my units of feet because that's what I want to stay in, so I'm good. And my minutes will cancel, right? And I want to keep my units of seconds. So this mathematically is my expression, right? This mathematically is what I'm hoping for and what I'm looking to do. And so here I have 200 times 5,280 over 60 times 60. And I can simplify the bottom to be 3,600 if I want. I'm going to quickly use my calculator just to save some time so we can get to the other problems. Then 200 times 5,280. Okay, then divide by 3,600, and I'm going to get 293.33, and this is in feet per second. Quick note, always I want to probably circle what it is that I'm looking for. It says, what is paragraph maximum speed? Well, I'll try in feet per second. It says round your answer to the nearest whole number. This, so I don't make a careless mistake, nearest whole number is 293 in this instance, and I'm done, and that's it. Okay. So this problem, the reason why I did it is that it's connected to rates, given the fact that you see per, and I wanted you to see kind of what to expect if they give you something with a unit conversion, right? But remember, if you have these parentheses here, that's what it's referring to by unit conversion, and then you have to follow the unit conversion method of setting this up in order to get your desired, essentially your desired units of what you're looking for. And also notice, this is open-ended, right? So if you remember last time for what we discussed, your open-ended, like this, your open-ended, it needs to be a positive value. It cannot be negative. And there's also no pi, right, for what we mentioned. There's no pi inside of your answer choice, and there's no radical sign inside of your answer choice. Okay? There's no radical sign. And because, so this works, this matches all three of those conditions, and because it matches all three of those conditions, and I'm purposely rounding down here for the 0.33, then that makes it, that's essentially what makes it work, okay? All right, so let me do this. I see some of you guys have a few quick questions, so let me check. Okay, so if there's parentheses, it automatically unit conversion. Yes, yeah, so this is the anonymous attendee. I'm not quite sure, but yes, if there is parentheses, automatically unit conversion. Okay, that's a good question. And anonymous attendee, you will have to specify your name. Okay, so that, because otherwise, fortunately, I will have to dismiss you from the webinar or from the seminar. But I like you and I want you to stay. Okay, so you have to specify who it is. Sorry, it's Caitlin for okay, that's all right, Caitlin. All right, thanks for clarifying. I appreciate it. Okay, all right. So let's see here. Let's go to the next one. All right, so I hope look, the big thing so far, and remember, a lot of this is kind of repetition. You guys are definitely going to get better at this as it goes on. But the one thing I want you guys to pay attention to is the interpretation thus far, right? So I'm trying to do problems intentionally that make it easier so you can interpret things, right? Like this in this instance, right? Where here I see 16 ounces equals 1 pound. That should immediately tell you you're going to have to do a unit conversion, okay? So that's kind of the reason why I'm doing it. So that way it makes it easier for you as we go forward. Okay, so in 1854, during the California Gold Rush, each ounce of gold was worth $20. So this is what we want to do. 1 ounce equals $20, right? I'm going to start labeling what we refer to as unit conversion. It says the largest known mass of gold found in California was worth 62,400 in that year. What was the weight in pounds of this mass of gold? And notice it says in pounds. What was the weight in pounds? And I'm trying to figure out question mark pounds of this gold. And this is what they give me. So they give me 16 ounces equals 1 pound. And I'm going to need to take my money value, okay, That's what I'm starting with. And I will need to convert this money value first. Let's sort of do like a quick brain map, okay, to make it easier for him. I'm going to do this value into ounces, and then from going from this money value to ounces, then I'm going to be able to go from ounces to pounds, right? Like this. Then I'm going to be able to go from ounces to pounds. And I have seen, to be fair, I have seen unit conversion problems where it's totally about the process. It doesn't matter if, you know, they'll purposely use terms like hiddly winks and doodly, what they'll use terms that aren't real, right? And they do that on purpose. So if you understand the process, that's the more important thing. They don't want you to understand, you know, they don't want you to memorize what the actual unit conversions are. They want you to know how to do unit conversion in general. And even I think practice test 1 has a question that does that. It's like, you know, they mention like some made up kind of almost like some made up unit conversion. But all right, here we have 62,400. This is my starting value, right? And then I'm going to go to ounces. So I'm going to go times. Now notice what happens. This is my dollar sign. This is my unit, okay? So this, I'm going to put then $20 down here, because these are going to be my units, and I'm going to put ounces on the top. Also, quick tip, this might help you as you're solving things, is that your desired unit, the thing you want to stay, should generally appear in your numerator, right? The thing you want to stay is generally going to appear in the numerator. The thing you want to cross out is generally going to appear in your denominator, so that way it's gone, okay? All right, cool. Let's keep kind of going on. And so here I have 62,400 times 1 ounce over $20. Now notice what I did. I'm in ounces, and I want to now go from ounces to pounds. So I'm going to put 16 ounces here on the bottom, right? This is my coefficient, or my number out in front. And I'm going to put pounds here on the top. And the reason I'm putting pounds is because it's my desired unit. My ounces will now cancel, well, would you know? And I am in, right, units of pounds, and this is equal, so it becomes 62,400 times 1 over 20 times 1 over 16. And when I break this down, once again, we're in question 31. You will notice a lot of your unit conversion problems are usually in the calculator section because the values they give you. So 62,400 and then divided by 20 equals, and divided by 16 equals, and should be 195. That's what I'm getting. So here I have 195 pounds. I'm in the open-ended section, right? So positive, no pi, no radical sign. I'm good to go. Okay, awesome. All right, cool. So I think you guys have a pretty good understanding of just general like rates and proportions. What I would encourage you to do on this here is to essentially kind of keep going forward, right? Do as many of those problems as you can. I'm going to do a few percentages problems so that way you guys can get a kind of a feel for those of kind of how to do them and what makes the most sense. And then I'm going to hop down to some algebraic expressions problems, and then we'll kind of keep rolling, okay? But I want to make sure, and yes, I will make sure to upload this video. I will make sure to send it to you guys so that way you have it, all right? Because this video is not something we currently have on our platform, so I want to make sure that you have it so it's a little bit more unique, okay? But always, I'm here for you, so feel free to reach out if you need anything, okay? Now, when we are, let's slide back real fast. Okay, so moving into percentages problems, the big takeaway for percentages on the SAT is that they generally do not do it in classic math-wise. Now, what I mean by classic math is that percentage problems, you usually think of, hey, here's my amount paid, okay? And I have, let's say, some sort of original price, right? And then you will either, and then you do your original price, and then you're either going to like add your original price, let's say, times your tax increase, or like times like some sort of percentage increase, like if you're getting taxed by some sort. And notice you're adding this here. So you could use this formula if this is what you're kind of accustomed to. You could also use this formula here, which is amount paid is going to equal your original price, okay? and then minus, right, and then here's your original price, let's say, times, once again, your percentage of this, right, percentage of the original price. Okay, and this isn't, so this is to represent an increase. Let me label it a little bit better. And then I'm going to show you the cheat, right? I'm going to show you the quick way of doing this and the way that they expect you to be able to do this, right? So this is to represent increases because there are taxes and there are like population increases or things of that nature. This here is to represent decreases, and the decreases, for the most part, okay, the decreases are like discounts. Like if you get some sort of percentage discount that's associated with the price, okay? Now, here's the other thing. In order, and I'll show it to you both ways so that way it makes sense to you. But really what you're going to do for most of your increase problems is you're simply going to take your original price like this, right? Now write it up here. You're going to take paid equals your original price, and then you're going to do times, and then it's going to be 1 point something, right? So the 1 point something is going to symbolize your percentage increase for what it is. Okay, so there's your percentage increase. The 1 signifies the fact that it's 100% of the original price, and the percentage increase is representing the fact that it's over what was the initial 100%. Most of the time, to be fair, on the SAT, it will be in this form, okay? It's also much faster to do in this form. If here you have your discount, right, for your paid, your original price, and then minus original price times percentage, most of the time on the SAT, this is what they'll do. They will do the paid equals your original price times, now here's the catch, your percentage remaining. So you deduct whatever it is, right, from it. So your percentage remaining. And I will show you both. Take a quick screenshot if you need to, but I'm going to show you both examples so that way it makes a little bit of sense to you, right? And the reason why I'm purposely showing it to you this way is because a lot of answer choices on the SAT actually reflect this way, right? If you need to do it old school, totally fine, whatever works best for you, all right? And then I'll also show you how to use your answer choices as a guide to like help you. Okay, so let's see, here we are. It says, a customer paid $53 for a jacket after a 6% sales tax was added. So here's what we have. We have paid equals, and they're saying sales tax. So here's original price times a 1.06. So I do 100% of my original, and then I do plus 0.06 sales tax, okay? Was added. What was the price of the jacket before the sales tax was added? So they want to know what is the original price. Now you see how this is so much easier to do. Or if I have $53 equals what was the original price times 1.06, then I can just divide both sides by 1.06, divide both sides by 1.06, like this. And then my 53, right, divided by 1.06 is going to give me $50. Yep, so this should be my original price here. So B should be my answer. Now, this is way more efficient to do than if you were, for instance, going to do paid equals my original price, which is what I'm trying to solve for, times, I don't know, by the way, original price, so this would be a plus, plus original price times my 6% increase, right? You see how this makes it more complicated simply because of the fact that I have now 2 positions for my OP? It's way more efficient for whenever you're doing percentage increase problems, okay? Whenever you see the word tax, right, or some sort of percentage increase, your easy way of doing this is do 1 point percentage increase, okay? 1 point percentage increase. Whenever you see a percentage decrease or some sort of discount, you do the original price times your percentage remaining. Now, percentage remaining is, let's say it's a 30% discount, right? Then you have 70% remaining. That's what I'm referring to. Okay. And I'll do another problem that looks like that as well. So that way you guys can see both sides of it. All right. So I'm getting a few questions. So I'm gonna pop onto that real fast. Okay. And let's see here. Let's go here inside of the chat. It says, that's way quicker. Yeah, yeah, it is. And here's the issue: is that a lot of students who don't know this quick tip, then it makes it tough, because there's going to be problems on the SAT, and I'll show you. There's plenty of problems on the SAT where they will purposely have 1 point something, and then they will purposely have like 0.99 of something. And you're wondering to yourself, where do they get these values from, right? They're getting these values from the idea that you're doing it the most efficient way, because this way here is tough to do, right? When I'm trying to solve for both. This way here is just one step, and I'm sometimes even do it in my head, right, as I'm setting these up. Okay, so your answer here is going to be B. Let's move on to some of the other ones, and I'll show you other examples. Okay, here's a good example of a type of problem where they have various discounts. Okay, it says a piece of furniture is listed at $145, is offered an 8% discount. Now, once again, whenever you see the word discount, okay, what you're going to want to do is you're going to want to multiply by the percentage remaining. Okay, by the percentage remaining. So it's not it's not this. It's not 0.18, because that represents an increase. Okay, so anywhere where you have 1.08, that's not going to be right. Right, so it's usually A and C are most likely not going to be right. In this instance, you have 8% discount. So you have this. You have 92% remaining. And if you have 92% remaining, this becomes 0.92, because they'll purposely convert it to a decimal. So it's going to be B or D, right? Because that's where the 0.92 is coming from. Then it says the store then offers an additional 5% discount for those customers who pay in cash. Well, this once again is a discount. So I am not going to do 1.05, right? Instead, I'm going to do my 5% discount is going to become a 0.95, because that's 95%. So I should have this in my answer, and I should have this in my answer. Okay. It says, which expression is equivalent to a customer paying in cash, meaning that both of these discounts will be applied. And if both of these discounts are going to be applied, then it appears as though D is going to be my answer. Okay. Now, where does the 145 come from? That's your original price. So here you have your original price times your 0.92 times your 0.95. Okay. Do one last tip is, with respect to percentages, make sure to not get original price and what is paid confused, because sometimes what is paid, right, is what they will give you, and they will ask you to solve for original price, like in this instance, right? So 0.92 times 0.95, right? If I wanted to solve for original price in this instance, then I would divide by my 0.92 and my 0.95. It depends, though, on what they're asking for. So just remember, the amount paid is the overall amount. The original price is what you start with. Okay. All right, guys. I hope that really helps, and I hope that clarifies a lot of like various percentage problems. I'll do one more that's probably a little bit more related to the SAT of what you would normally see as well, because they don't do a lot of. Sometimes they will purposely set one value equal to another, which is kind of what number 9 looks like, essentially. So here we have, based on 2010 U.S. census, the population of Milwaukee, Wisconsin was about 96% of the population of Baltimore, Maryland. That means that my Milwaukee, Wisconsin, right, Milwaukee, says was about 96% of the population. That means that this equals my 0.96 of Baltimore, I believe. Right, and in 2010, if Milwaukee's population was this, which of the following is the best approximation of Baltimore's population? So Milwaukee is 96% of Baltimore. So Baltimore has to be the larger number, right? Because if it's 96, then Baltimore is the 100% of this example. And so M is Milwaukee's population, B is Baltimore's population. And then they tell me that the population was 595,000. So I'm just going to plug this in here. 595,000, like this, equals 0.96 B. And it says, what is the approximation of Baltimore? Well, just solving algebraic expressions 101, I'm solving for B. I'm going to divide both sides by 0.96 because these are being multiplied. So now I can cancel these. And this side here, then I would divide by 0.96. One thing you'll notice is there's only one answer choice that's higher than 595,000. So it's got to be this one. But still, what's more important is that you know how to do this, not just, hey, yeah, there's only one answer. Because what happens if they gave you 610,000 or they gave you 605,000? You would still need to be able to do the math, and certainly at this level, to at least be able to express it. So 595,000 and divided by 0.96, and yeah, so you end up getting, actually, just to be clear, 619,000, I believe, and 791.67. But notice this wording here. It says best approximation. That means that whenever you have best approximation, that means that you're rounding and you need to be able to estimate. Okay, that's 9 out of 10 times what they're referring to. So this answer is definitely closest to A, because this is your 620,000, right? If I round this, A is going to be the closest answer choice. Okay, awesome. All right, guys, hope that helps. Let's move into some other types of topics. That way it makes it easier for you. We can always come back and do number 8, but what I would definitely encourage you to do, like always, attempt to do these for homework as much as possible. And we have dozens of videos on all of these, but I will gladly fill in the other things. But I want to try to cover other types of problems so that way you guys see it and it makes more sense to you, okay? Now, arguably, algebraic expressions, I would say, is probably one of the easier topics that are covered on the SAT. But I want to make sure that you understand how to interpret them, of just knowing what to do and essentially what to. Now, these are more of the classic of what you would expect. So here it says, if A over B equals 2, what is the value of 4B over A? So what you need to figure out, and this is what you want to circle, okay? You need to figure out what is given, right, as we've talked about before, and how you're going to utilize that given in order to solve for this expression in some way. Because of the fact that I have A over B equals 2, one thing I probably would note to make my life easy is if I solve for A, all I have to do is bring this up. I get A equals 2B. And then if I get A equals 2B, then I just plug it in here, right? And then I could substitute it in. And if I substitute it in, I just end up getting 4B like this over 2B, which these simplify, 4 over 2, and then I get 2. So 2 should be my answer for this. The question is, why did I immediately just bring the B up? It's because then I have this in a numerator and I'm not dealing with fractions. And by not having to deal with fractions, my life is easier, right? So that's essentially the strategy of the reason why I did that, okay? Now, always, most of the time for whenever you have algebraic expression problems, you want to pay attention to what is given, because odds are you will need to manipulate it in a certain way in order to solve for what you have to plug in, okay? Awesome, guys. Hope you're getting a lot out of this in terms of what to do and solve for. So here it says if t plus 5 is going to be over t minus 5 equals 10, what is the value of t? Well, I could theoretically like factor this out if I wanted to, but I honestly think what I'm just going to do is just cross multiply. Also, what I'm going to do, quick tip, so you don't get things wrong, I'm going to circle this, right? And I'm going to, the reason why I'm circling t is, believe it or not, you'd be surprised how often you know how to do the problem and you solve it, but you don't solve it all the way, or you solve it too much or something. So this helps to kind of keep me on track for what I'm going to need. Okay, so here I have t plus 5 over t minus 5 equals 10. I'm going to cross multiply. I'm going to get t plus 5 equals 10, and then t minus 5. I'm going to distribute like this, and I'm going to get t plus 5 equals 10t minus 50, right? Now I'm going to bring the 5 over. Actually, you know what I'll do? I'll bring the 50 over so that way it stays positive. Yay. And why did I choose to do that? All my answers are positive. Yay, right? So that helps kind of guide my thought process. So I'm going to get t. And remember, if I add 50 on both sides like this, add 50 on both sides, this becomes positive 55, right, equals 10t. And then I'm going to subtract t. And when I subtract t on both sides, I'm just going to get 55 equals 9t, I believe. And now I need to divide, right, both sides by 9. Why? Because I'm trying to get t by itself. So this is what I'm trying to isolate. By both sides by 9. And I get 55 over 9. And yay, right? And so now I'm finished and I'm done, okay? There are other types of problems where, depending on the answer choices and depending on what they're giving you, there might be a different style. You may not distribute, you may distribute. That's why I'm saying you have to use what is given in order to guide you. It's not cookie cutter as in this is exactly what you do in every single instance. It's completely dependent upon the conditions of what they're giving you and sort of using this as a map of what to do, right? Even something as simple as, hey, do I make these both negative? No, right? Then no, I don't do that because of the fact that the answer choices help to guide me. So that's always how you want to be thinking about the SAT to help you the most, okay? So let's see what some questions you guys might have. What I did for this one was I changed this to 4 over 4 and it equals 2, and then I solved there, and I'm talking about the problem before 10. Yes, yeah, yep, that's a great solution. That's perfect. Most of these problems, once again, are I'm not going to underestimate it because I know they can be a little challenging. But to be fair, on the actual SAT ranking, they are considered the easier problems. Okay. Perhaps the percentage problem would have been a medium problem, but most of the problems I'm doing right now are fairly easy to show you kind of how to interpret and what to do. The problems I'm going to be getting to probably in about 10 to 15 minutes, those would be considered more of the easy to, I would even say, difficult problems, right? Because generally the SAT ranks it on a level of 1 through 3. So whether it's easy, medium, or hard, okay? Now, this problem is a perfect example of how to overthink something, okay? So it's in the equation above, which of the following is a possible value of x plus 1? What you want to do is you want to interpret, okay, what do I see here? I see x plus 1 equals 2 over x plus 1. I'm sure many of you are probably thinking to yourself, yeah, I need to cross multiply, right? Because I need to get this out of fraction form, which is correct. And when you cross multiply, you end up getting x plus 1 like this times x plus 1 like this equals 2. Now, those of you that are not familiar with the strategies that I've been kind of preaching, where you always interpret what's given, you always interpret what the concept is, and you're always trying to figure out what is the way to relate these things together, okay? If you decide to FOIL here, right? If you decide to FOIL, then you're not thinking about how they relate. Because if you FOIL this, then you then get an x squared, right? And you end up getting what? X squared plus 2x plus 1. That doesn't help you though, because notice your answer choices here, right? If you do this way, basically what I'm saying is that you end up with factoring it back anyway, and then you have to solve for x plus 1. So if you end up foiling it, that's just going to be honestly, it's not going to be the best use of your time. Instead, what you want to figure out is, hey, they're looking for x plus 1 together, not separate. So instead, what you want to do is, hey, let's combine these. I have x plus 1, and now I'm going to make this squared equals 2. And what would you know? In order for me to remove the exponent on the outside, I'm going to take the radical of both sides, right? Now I get x plus 1 by itself, right? Which is what I was attempting to solve in the first place. And check it out, it's just radical 2. So radical 2b is going to be my answer. That's what I mean by using the answer choices, as well as making sure that you are fully aware of what it is that they're asking and you're not doing too many steps, right, in order to solve. Because if you decide to FOIL this, then you're being a hero, right? And I'm sure you might end up working your way back I hope so, right? But what's odd is that you could do this problem in like 5 seconds in your head, right? But many students, if you decide to foil this and do too much classic math, it becomes an issue, okay? And that's what you want to pay attention to is what is it that they're giving you and how does it relate to overall what it's asking you to solve for, okay? All right, so key strategy there. So for 15, we have if ax plus 2 times bx plus 7 equals 15x squared plus cx plus 14 for all values of x, and it tells you a plus b equals 8, what are two possible values of c? Well, remember what I told you, okay? Everything is a tool, okay? I want you to remember this because this would be considered a medium to a hard problem, okay? Everything is a tool. Now, so let's examine what is given in the problem. So that way it makes it a little bit easier for you. It says if ax plus 2 times bx plus 7 equals this, that's a given, okay? This is a given. It also says if a plus b equals 8, what are two possible values of c? A plus b is a given. Now, this is sort of the wild card. Why are they giving you a plus b? Why is it necessary to give you a plus b in order to solve this problem? That's what you need to think about. And remember, everything's a tool. So let's examine the problem where we have ax plus 2 times bx plus 7, and it tells you 15x squared plus cx plus 14. Well, the first thing you probably want to check is, do these match? Like, does 2 times 7, when you're foiling, will that give you 14? And it will, right? Because if you remember with the FOIL, right, your first, outer, inner, last, this is your last, right? So this is what that should be equivalent to. Your outer and your inner, right, these will combine and these will give you your middle term, which is what they want you to figure out. And then your first should be this, right? Your first should be, and just foiling 101, should be ax times bx, right, should give you 15x squared. So I know that ax multiplied by bx is going to give me 15x squared. Well, check this out. abx squared equals 15x squared. These can cancel, right? And I now have AB equals 15. Well, that's why they're giving this to you, okay? Does anyone want to take a guess what they think A and B are equivalent to, right, as we do this? So if AB equals 15 multiplied together, and you know A plus B equals 8, let's take a wild guess what we think A and B are going to be equivalent to, right? Because what you're now going to have to do, you know that 14 works with the 2 times the 7, and you know that the 15 is what A times B equals. Then what you're going to have to do is plug them in, right? So now we're going to set this up in order to plug this in. All right, so let's see here. I see a lot of you guys are posting it in the question. Yep. Caitlin, great job. It's 5 and 3. To make this easier, just so as I'm like clicking through, do me a favor and post it in the chat. The chat is it just immediately pops up every single time. But the question and the answer feature is also very good. But if you post it in the chat, then I can see it without having to click through. Right? It makes it a little bit easier as we're covering a number of different problems. All right. So here's what we're gonna do. Once you know, or once you think it's going to be 5 and 3, right? Which two numbers multiplied together will give you 15, but then when added together will give you 8. You're right. It's going to be 5 and 3. So instead, what we're going to do now, and here's the other tip. It says for all values, what are two possible values of C? And notice C is positive. So all I'm going to do is I'm going to plug them in both ways. I'm going to plug them in both ways, and I'm going to check. I'm going to like affirm of like what my answer should be. So if I do 5x and then 3x and then reverse it here, I'm going to do 3x, I'm going to do 5x, okay? And this is plus 2, and this is plus 2, and here is plus 7, and here is plus 7. Okay, great. Now let's simplify this. 5x times 3x is 15x squared. Square here. 5x times 7 is plus 35x. 2 times 3x is plus 6x. 2 times 7 is plus 14. The plus 14 plus 15x squared, that works. So this is now my middle term. This is 41x. 41 should be my answer. It's going to be D, most likely. 3x times 5x is 15x squared. Here, 3x times 7 is 21x. Some of you guys are probably already ahead, which I commend you. 2 times 5x is going to be 10x, and then 2 times 7 is going to be plus 14. And these added together, my like terms, are going to be 31x. So 31 should be my answer. And yeah, D is definitely my answer then, right? So the reason why I like this problem as much as I do is that you sort of don't know where to begin if you don't connect this dot, right? If you are not thinking to yourself, why did they give me this piece of information? Why is this a given? Why is this a tool? Then you kind of will just, hey, how do I solve this problem? It doesn't make any sense to me. The moment they give you a plus b equals 8, then it starts to register to you, hey, well, where does this come from, right? And if I can do a times b, right, equals 15, then you start to kind of fill in the pieces. But you have to think about it that way. And that's the reason why during our first session, we spent kind of a considerable amount of time making sure that as we're going through each problem, that is how you're analyzing these problems, right? That's how you're thinking about it. So that way things don't appear to be random, okay? For number 20, it says here, the expression above can be written in the form of a y squared plus b, where a and b are constants. What is the value of a plus b? Notice what I'm doing though. I am circling what is given. So this is going to be equal to the form of a y squared plus b, but I am circling what they are asking for. So I do not make the mistake of just solving for a or y or b and then not actually solving for what they're asking for. So let's take this form here. We have 7,532 plus 100y squared. And then I'm going to put this in parentheses for the time being, and then plus. And then what I'm going to do is I'm actually going to distribute this now, make it a little bit easier. So I'm going to make this 100y squared, and 10 times, right, my 110 becomes negative, why am I blanking here? Negative 1,100, right? And then because of the fact that these are both positive and able to be simplified, I'm actually just going to take away my parentheses, right? Normally I keep them in just in case, just to see, but because this is fairly straightforward. Now notice what happens. Really all I'm going to do here is just combine like terms, because I see what I'm looking for is a y squared plus b. So I need to get something in front of the y squared, and I need to get an independent value. It appears as though my a's, right, are going to be here because these are attached to my y squared. So I'm just going to add these together, and I'm going to get 200 y squared, good. And then I'm going to do my other values here, right, when I simplify. And this is going to become 6,000, and it's going to be positive because this is a greater number. So this has become 6,000. I think it's 432 if I'm right, just doing this off the top of my head. And then, so this is why I'm saying it's always important to double check, because I did the hard part, right? I did the hard part. I figured out the ay squared plus b. I figured out this was a. I figured out this is b. The easy part to mess up is solving for the wrong thing. So here's a, here's b. I add them together for 200 plus 6,432. I get 6,632, and that should be my answer choice. Awesome. All right, guys. So like I said, I hope this is helping. I hope it is clarifying a few things of generally how to think about the problems, right, as we're going through. And this will get easier, trust me, right? So what I'm gonna do now is I'm gonna switch it up a little bit, and I'm gonna go to a different section, like in terms of like other types of problems to tackle. But as always, I encourage you to do as many of these problems as you can independently. 2x plus 1 equals 5, and it says if a and b are the solutions to the equations above, what is the value of a minus b? Notice absolute value, so this is what I'm trying to find, okay? Right, always circle what it is that you're trying to figure out. It does say 2x plus 1 equals 5, so notice this. It says 2x plus 1, absolute value equals 5, and it tells you these are both solutions. So what you want to actually, I think, to tell you the truth, I think it says, what is the value of a minus b? I think this is still, I think the answer is actually going to be 5 because of because of just how absolute values work. But you, regardless, what you want to be able to do is solve this. And you want to be able to solve it where you break it down into your two absolute value equations. So here you have your standard 2x plus 1 equals 5, okay? Your other equation is going to be 2x plus 1 equals negative 5. Or you just have to change the sign of one of the sides, okay? It could be negative 2x minus 1 equals positive 5, or you can do 2x plus 1 equals negative 5. I generally just flip the sign of the one side because it's less to distribute. So here I have 2x plus 1 equals 5. I get 2x equals 4. When I subtract them 1 on both sides, I then get x equals 2, right? Here, if in this instance. And then over here, I get 2x, and this is, I'm going to subtract 1 to both sides, and then we get minus 6. And then when I divide here, I get 3. So x equals negative 3. Now, here's the thing, though. I have to plug them both in. So I have to figure out, okay, here I have a minus b, right? And then I have a minus b. But I have to plug them both into the instance of, like, what is a, what is b? And theoretically, I should get the same answer, okay? Like, theoretically, because there's only one answer to this question. So here I have, let's do 2 minus 3, which, yes, will end up giving me a absolute value of 5, which does give me 5, and what would you know? And then here, if I did it really, really right, then I should get my equals, this should be my absolute value of minus 3, minus 2. This will give me absolute value of negative 5, which does also give me 5. So yeah, 5 is going to be my answer. Awesome. Okay. All right, guys. Hope that helps of like how to break it down. Remember that whenever you have your absolute values in general, right, you just want to simply, and this works for the ACT as well. Okay, the ACT will do the exact same style or exact same type of problem, probably even less steps to be fair. Is that you simply want to take the regular kind of like positive value, and then the other one is you want to take and you want to flip it to the negative sign. Okay, so you just simply have both versions of as you're solving for solutions to the absolute values. Okay, because I think this one is a better understanding of how to use the givens in order to take the concept and then relate it to what it is that you're being asked to solve for. All right, here it says, which of the following complex numbers is equivalent to this? Now, quick tip, whenever they give you this, complex numbers, and whenever you see this, I equals a radical of negative 1, what you think about the moment they give you this, I equals radical of negative 1, and if you have like i's in your answer choices, right, you think of this, I squared equals negative 1. This is immediately what you have to associate. I squared equals negative 1, okay? What you want to pay attention to is that this says 3 minus 5i over 8 plus 2i. What you want to pay attention to is that in your denominators, right, in your denominator, there's no I, right? So the question is, how does that happen? Like, what mathematical way do they remove I from your denominator? And I hope you might remember, right, although I forgive you if you do, is that the way to do this is you have to what is called multiply by the conjugate. Right, so you're going to multiply by your conjugate of your mathematical term. So here I'm going to do 3 plus 5i, or sorry, that's not my conjugate. My conjugate is 8 minus 2i. The reason why I refer to this as my conjugate is because I simply take this sign here, and what I know that I'm going to end up doing is I'm going to get rid of my like term in the middle. So this becomes 8 minus 2i. And this is what I mean by this, just to make it clear for you. Is when I multiply 8 times 8, right, I get 64. And I'll put this all in the denominator. 8 times negative 2 gives me minus 16i. 2 times 8 gives me positive 16i. Now, notice these like terms will cancel. Because these like terms cancel, that is why I multiplied by my negative 2i, right? Or in this case, my conjugate. And here's the other catch. My positive 2i minus my 2i will give me negative 4i squared. The moment that I have an I squared, it's not an I squared anymore. It is now a negative 1. So now I can take my negative 1 and I can plug it in wherever I see I squared. And that's what you want to associate with, right? At the moment, wherever you have I squared, you're going to plug in a negative 1. okay? So therefore, when I plug in my -1, there's no more I in my denominator. There's no I. And if I don't have an I inside of my denominator, then that is what makes all of these like a whole number to make it easier. I'm going to do the same thing at the top. 8 times 3 is going to be 24. 3 times -2i is going to be -6i. -5i times 8 is going to be -40i. Notice these won't cancel, and that's why the i's are all still present in your numerator. And then here I have my -5i times my -2i is going to give me positive 10i squared. Okay. Also notice that this I squared, I'm going to plug in another -1 here. Hope you guys are like paying attention. Hope this is making sense. And then I'm going to get the triangles in a little bit. So let's plug in my -1. I'm going to do, right? Let's erase this. Let's erase this. And then as I plug in my -1, this is what it becomes. Plug in my -1, this is what it becomes. Now I'm going to bring this down here, and I'm going to get 24 minus 46i, and then this is going to become -10, okay? And this is over 64 plus 4, right? This becomes a negative times a negative becomes a positive. So this is going to give me 68 on the bottom, which is probably the easier way to look at this initially. So this is going to be 68 here. And on the top, I'm going to have 24 minus 10, which is going to give me my 14, right? So 14 minus 46i, right? Going off the page a little bit, so I'm going to bring it back. Here I have my 14 minus 46i and over 68. Cool. Now here, right, I'm going to simplify this, and I'm going to use my answer choices as a guide. Yeah, it's going to be D. D, right, because if I simplify both of these, and if I separate them, actually, no, it's not. Sorry, it's not going to be D. Hold on. And the reason why it's not going to be D is I chose too soon, is because of the minus sign, right? I have to subtract these. So this is going to be my minus 46i, so it's going to be C, right? Because of my minus sign for what I see here. So D is a positive, so that's not going to be the case, okay? So my answer in this case is going to be C, because when I simplify, 14 divided by 2 is 7, 68 divided by 2 is 34, 46 divided by 2 is 23, 68 divided by 2 is going to be 34. So C is going to be my answer. Awesome. The primary topics that are going to be covered are going to be triangles and circles and essentially kind of supplementary angles, complementary angles, things of that nature, right? Now, the first thing that you see here is going to be in the figure above, point B lies on AD. What is the value of 3x? Well, I'm circling this. I'm going up to my diagram. I see here that they're giving you a 90 degrees on one side, which tells you that the other side here, and we would define this as being both of these angles all the way together, this is 180 degrees, okay? And this 180 degrees is what this angle, right, ABC, and these angles all are going to be together. Now this is 90 degrees, so that means that x plus 2x plus 2x, these will equal 90 degrees, right? And we refer to these angles, as being complementary, right? So that's because the sum of those angles are going to be 90 degrees. So here I have 5x equals 90 degrees. And if I were to divide both sides by 5, okay, I was going to say 14 at first. I was like, nope, that doesn't feel right. So x is going to be 18. Now, right, look what they did. So that's there, but I'm not done, right? I'm not done because I'm trying to figure out 3x. I'm not trying to figure out x. So I need to make sure that I do 3 times 18. I don't make a rookie mistake. 3 times 18 is therefore going to be 54. So 54 is going to be my answer to this question, okay? Quick tip. Whenever you have two angles that are together like this, these are referred to as, whenever they're equal to 180 degrees, these are referred to as supplementary, okay? Whenever you have two angles together and they are kind of like this, or even like multiple angles, and they're all within 90 degrees, they are referred to as complementary, okay? I generally actually, and maybe this might help you, I generally always remember the 180 is supplementary because it's higher in the alphabet. and the C is lower in the alphabet. So that's how I remember like how to distinguish which one is which. I don't, maybe that helps you guys. I hope so, right? Of as it goes through. Okay. All right. So let's move into some of the other problems. This is a pretty advanced, I would say, angles line problem. So let's do this one, and then we'll move into some of the other different types of triangles. Okay. So here it says, what is the value of x? Intersecting lines R, S, and T. So here we have here S, and one thing you want to pay attention to, if you remember this like correctly, is that, and here we go, quick crash course of geometry 101. Okay, this angle here and this angle here would be referred to as vertical angles. So these are going to be equivalent. Same as this angle here and this angle here. So technically, I could figure out 23 in this other angle. Okay. I can also figure out this angle here being 106 if I need to. I could, because of the position, I could figure out 106 and this angle here, because these two things together are going to be supplementary, because this is 180 degrees, right? But the question is, what's the fastest way to get to x, right? That's what you need to examine, is what is the fastest way to get to x? I actually think the fastest way to get to x is to go this way, right? And if I go this way, then I know the sum of this triangle that you see here, which is going to be 23 and 106, right? And then if I do 180, right, minus my 106, that's, yep, 74, right? So 74 here. And then that tells me that the sum of these three angles here, right, is going to be 180. And then this is going to be the other side. But also, quick tip, you can immediately tell that 74 plus 23 is what this side is going to be, right? Just because it's also 180. But I'll break it down for you. So 74 plus 23 plus x in this instance, these are going to equal 180. So what I'm going to do is I'm going to do 180 minus 23 minus 74. Okay, so 180 minus 70, or minus 23 minus 74 equals 83. Okay, so there's that. This with this angle here equals, this is 83. And if that angle there is going to be 83, let me make this easier for you. And here we have, this is 83. Okay, now that tells me that this here is also equal to 180, because these are technically going to be supplementary, right? They're on the same line. They're linear, for instance. So that tells me that 180 equals x plus 83. I'm going to divide or subtract both sides, right, by 83. And then I get 180 equals, right, my 180 minus 83. Sorry, a lot of this I would be doing in my head. So so 180, right, my minus 83, and I get 97, yeah. Which should be my answer. 97 should be my answer. And I was able to quickly do that because 74 plus 23 also gives you 97, right? And that's how I was basically solving it, because these two sides have to be equivalent to this because they're both working off of 180. So just another kind of quick tip of various things to solve for. I will say though, to make it so that way you're not hey, what rules of geometry do I need to use? You will absolutely need to be aware of vertical angles, okay? You will absolutely need to be aware of supplementary and complementary lines, which I would say you're probably going to use the most often. You will also need to be aware of the rule where if these lines are parallel and you have what is called a transversal, which is a line that cuts this and essentially, if it cuts it and essentially intersects it, and what you want to be aware of is that this here and this here are going to be equivalent, right? Which therefore makes these vertical angles here equivalent. And there's like special names for everything, right? Like alternating interior angles and all these other things. You don't actually need to know all the special names, but what you do need to be aware of is kind of how things are going to be set up. And likewise, like this angle here, right, is going to be equivalent to this angle here, and that's alternate interior angles. If you might remember and this was the easiest for me to ever remember, is that if it formed like a Z, right, the angles that you see here, right, this guy and this guy, right, if they formed like a Z or reverse of that, if they formed a Z the other way, like here and here, right? But the most popular ones, and you can always solve for everything, are going to be vertical angles and alternate interior and alternate exterior, okay? Right. Hope that helps so far. Let's do a triangle problem. With respect to triangle problems on the SAT, you will have various concepts, but most likely on the SAT, for triangles, you will have to pay attention to special right triangles. You will have to pay attention to SOHCAHTOA for triangles. And you want to make sure that you're aware of Pythagorean theorem. A squared plus B squared equals C squared. You also finally want to pay attention to, and probably the most popular concept that they ask is similar triangles. They love to do similar triangles because it's based upon scales and proportions. So the first problem I'm going to do is actually going to be a mixture of a few of these concepts. That way it makes it easier for you guys, okay? So let's do this. And now let's back on down, and here we are. Now, as we're interpreting this problem, one quick thing that I'll say is if you have two triangles connected to each other, like such, where you have one triangle inside of another triangle, okay? The moment you see this, and they tell you this, and here's the trick. It says in the figure above, BD is parallel to AE. What is the length of CE? I want to make sure that I'm quickly kind of identifying the section that they want me to find. But this word parallel here, this is to signify that you're going to have similar triangles, okay? This is going to designate similar triangles, designate similar triangles. And let's quickly kind of rehash what are similar triangles, okay? A similar triangle is when you may have two triangles where their sides are not equivalent, okay? Their sides are not equivalent. The sides are proportional, technically, okay? But the angles within are congruent. So the sides are proportional, right? Meaning they're on a scale, and the angles are congruent. That's usually the proper term. So angles are congruent, which means the angles are equal, okay, within. One master tip I will give you is that whenever you identify the fact that you have a similar triangles problem, what you want to do is you want to draw a quick sketch, okay? So draw the triangles, draw them separately. And I know some of you were probably thinking to yourself, yeah, but this is going to take more time. It's because the triangle problems aren't really that hard. It's a matter of you organizing your information, because not every triangle problem is going to look like this. Some triangle problems may look like this. And you're going to have to pick and choose which sides are actually equivalent to each other, and that can get a little more complicated. So take the like 5 seconds to just draw the scale, right, accordingly, and visually it's a lot easier for you guys to identify it. So here's what I'm saying. Here's my C, here's my D, here's my B, okay? Here's my small triangle. Now, because of the fact that this is parallel, B will equal A. And if B equals A, right, then I'm going to put A on this side. C will equal C because these are both the same angle. And D is going to equal E, right, because these here are going to be such. And this is what I'm talking about before, where let's say you have two parallel lines and you have a transversal. This is what you see, right? This would be E, and this would be D. It's just they stop. The lines don't keep going. But if you drew like an imaginary line, if you like dotted this up, that's what this would be, right? These sections here. You don't see that in this illustration, but you have to sometimes be able to be prepared to draw larger images if necessary, so that way you can kind of connect what's happening. Now, notice what I did, okay? I lined up my figures and I lined up my angles. So D equals E, as such, C equals C, B equals A. Now I'm going to go and now I'm going to fill in my sides. So here's 18, AE, and this side here is 6, and this side here is 8, okay? Let's erase this to make some room, make it easier. and the side they're asking me for is going to be CE. So this is what they want, okay? The problem is CE is proportional to CD. I don't have CD. That's kind of the issue. But hopefully you remember this, that with triangles, you can use what is called Pythagorean's theorem, right? A squared plus B squared equals C squared. The C is representative of the side that's across, right, from the 90-degree angle. We also refer to this as the hypotenuse, okay? So this C here is going to be this side. You could theoretically figure this out really quickly if you know special right triangles, right? Because this is a 3, a 4, and therefore a 5. So this is going to be a 10. However, if you're a little stuck with special right triangles, then you need to be familiar a lot with Pythagorean theorem, because that's when you're going to use this, when you have a right angle and you have two designated sides and you're missing the other side. All right. But if I plug this in, I have, let's say, a squared plus b squared equals c squared. And my a squared, I'm just going to make, let's say, 6 squared. And then 8 is going to be my b squared. By the way, the a and the b are arbitrary. It's whatever you want to define them as. The c is really the only one that is definite. So the c has to be across from the 90-degree angle, which this is then c squared. 6 squared is 36. 8 squared is 64. This equals c squared. I'm going to add these together. I get 100 equals c squared. I'm going to do this and this, right, in order to remove my exponent. I then get 10 equals c, and what would you know? It's 10, right? Am I done the problem? No, I'm not. And the reason I know that I'm not done the problem is because I'm trying to solve for the side CE, not CD. CD equals 10. But here's the other thing. In order to relate similar triangles, what you want to determine is called the scale factor, okay? So the scale factor is looking at one side of the triangle and figuring out how it relates to the other triangle, right? So 6 and 18 are related if you were to multiply 6 by 3. Well, this side here, likewise, right? In order to figure out CA, it'd be 8 times 3, like this. This would give you 24. And likewise, 10 times 3 will give you CE. So this is times 3, which is going to give you 30. Therefore, making 30 your answer to question 18. Take a quick screenshot so you guys have it, so you understand kind of the basic breakdown of triangles. I'd be happy to do more triangles for you, so that way you guys have everything you need and are able to interpret it. But I purposely wanted to do this problem first, so that way you see the idea of similar triangles, and then also the idea of really how it relates to a squared plus b squared equals c squared, and really how to set them up. Okay, so one quick tip I'll give you is that if the triangles kind of share the same angle, or it's a triangle inside of a triangle, it is an immediate red flag, similar triangles, right? And so kind of help you along. Then draw your triangles, right, in terms of the scale to make it easier, and then determine what sides you need. What sides are proportional to each other, right? CB is proportional to CA, CD is proportional to CE, BD is proportional to EA. It's much easier to see it in this format than if you left it in like a tougher format, right? If you didn't draw them side by side. And the way that you actually line these up is just make sure that the angles are in the same position, right, throughout. That's your other kind of quick tip to make it easier for you guys, okay? So I hope you guys got a lot out of today. And if you have specific requests of, hey, Mr. Anthony, I'd love to do more quadratics problems or whatever it is, just let us know, and we'll purposely put a little bit of a priority on those types of concepts for you guys, okay?